So if you would recall, we've been talking about sinusoidal functions, and there's been this whole mess, but we broke down what each of these pieces mean. Notice that there are just 4 numbers here. There's the D, A, B, and C. Each one does something vertically or horizontally by stretching or by shifting. So there's 4 numbers. 2 of them are multiplications. The other 2 are additions. Sometimes it's a little bit better to write plus the vertical shift at the end. It's hard for me to get over writing the constant first. But I want to highlight that the constant term is a vertical shift. Then the letters like actually go in order. Each of these numbers tell us something about the function. The coefficient of the trig function is going to tell us the amplitude. That number might be negative, but that just changes what we think of as the start. So the amplitude is just whatever that number is out in front, the absolute value of that number. That's included by multiplication. The other number included by multiplication is b. It's b times x. B is going to adjust the period. In degrees, the period is 360 divided by that number. Or in our newfangled radians, we just replace 360 with 2 pi radians. I should say or. These numbers are included by multiplication, so they do things like stretch and squish. The other numbers C and D are included by addition and subtraction. So C is our horizontal shift. The other way we can think of horizontal shift, because there are lots, we saw last time, there are lots of ways of equations that we can use to represent the same sinusoidal function. So think of the horizontal shift as start here. The constant term is a vertical shift. That's going to be the middle. The other thing that might change is that we could be using sine or cosine. If we have positive cosine, that is A is positive and it's cosine, then we start at the top. Positive cosine starts at the top. minus cosine starts at the bottom. Positive sign starts off at the middle, but going up. Makes sense. The positive one is the up. Plus sign starts at the mid, going up. Minus sign starts at the mid, going down. These are the 5 questions that we got to ask ourselves. Whether we're given an equation and asked to produce the graph, or given a graph and asked to produce the equation. These are the 5 things that we need to know. Amplitude, period, horizontal shift, vertical shift, where we're starting. Remember, start always goes in quotes because the graphs go on forever in both directions. So it's a little fishy to say start here. But no one's complained about it yet, so let's keep doing it. All we're doing now, all we're adding to the game is that instead of everything being in degrees, we're going to start doing things in radians. But it's still just these 5 questions. Let's practice. Oh, I don't want to use 2. I'll use 3. That 3 clearly started life out as a 2. Our new default is going to be radians. I'm going to take out the pi, so it's going to be okay. Let's read the 5 things that we need to read. First thing we see is there's a -5 times the cosine. This is going to tell us 2 things. If we just look at the 5 part, that's going to tell us the amplitude. The amplitude is a distance. That's why it's going to be absolute value, because it will always be positive. The other part is the other thing that we get from this -5 cosine is where we're going to start. This is going to be relevant to what the horizontal shift has been named in this problem. So the negative cosine says we should start at the bottom. Two out of the 5 things down already. The next thing we can look at, the next thing we come across is the pi in front of the x. The coefficient of x here is pi, so the period, since we're going to be doing radians, is 2 pi divided by pi. 2 pi is the default period. We divide by the coefficient of x. So it's this pi up here that we divided by. So the period is going to be 2. We keep going on. And the next thing we come across is that x plus 1, which is a lot of horizontal shift for a period that's so short, but that's okay. Now, when we read the horizontal shift, we have to read this as x minus. It's weird. We think of it as being the opposite, but we're really thinking, what makes x plus 1 equal to 0? What I wrote on the previous page said x minus c. So when we see x plus 1, we got to think that's x minus what? X minus a negative 1. So that's going to be our start. And finally, the last number we come across is the negative 3. And so that's going to be our middle. This negative 1 is going to be our starting x. Yes. The negative 1 came from the default being b parentheses x minus c. So to read what the c is, we have to think x minus. And since it says x plus 1, that just means we've already simplified it, x minus a negative 1. But the negative 3 I just grabbed as is because our generic formula said plus d. That means plus a negative 3. So we don't have to change that sign. Any questions? It's a math thing you get used to. If you think about parabolas, the vertex form of parabola, a parentheses x minus h squared. Now we can start drawing our sinusoidal function. We got our 5 things: our amplitude, our period, our starting point, our horizontal shift, and our vertical shift. And we recognize what they all represent. So now I'm going to draw a generic sinusoid and fill in the points. So let's see, I need 2 on top, so this will be the middle. So in my usual fashion, I'm going to start at the bottom, and I'm going to do 3 dots to the middle, 3 dots to the top, 3 dots to the middle, 3 dots to the bottom, and that'll be 1 cycle. We put them 3 apart. Remember, each of these represents, in the generic form, each point is at the end of a quadrant. So this is dividing the circle up into 4 quadrants. And so 1/3 of the way off the middle, 30 degrees off the middle, is where we hit halfway. So instead of just drawing a line up and a line down, we want to bend it so that 1/3 of the way on each side of the middle points, we're at 1/2. Here's the next middle point, 1/3 of the way, we're at 1/2. 1/3 of the way, we're at 1/2. So we're dividing by dots 3 apart on horizontal, but I want easy things to cut in half. So 2 apart on the vertical. Make sure we draw something flat at the tops and bottoms. We draw almost lines through the middle. And we just make sure everything kind of matches up. Now I want to start labeling the things that that we know. So I got what one cycle is supposed to look like. I like to start with my vertical information first. So the first thing I like to put on, once I got my generic, once I figured out my minus cosine starts at the bottom. Then I like to get all my vertical stuff sorted out because it's easier. I just have to add the amplitude and subtract the amplitude. So I know that the middle is going to be at -3. So here in the middle, vertically, we're at -3. Then I go from the middle up the amplitude and then down the amplitude. So I add 5 and subtract 5. So we can see the top is going to be -3 plus 5. -3 plus 5 is 2. And the bottom is -3 minus 5, -8. First, I like to do the vertical shift. Then I like to include the amplitude. Now we can start labeling points. So our horizontal shift is -1. That's going to be our starting x coordinate. So down here, I'm going to have a -1. And the bottom is at -8. So that's the coordinates of this point. -1, -8. Next, I'm going to realize that where I wrote start at the bottom is exactly where I wanted to label the period. So I'm going to erase that and write it somewhere else. Once I have this starting point at the bottom, -1, 8, I know that the period is 2. So -1, the period will be between these 2 points. So -1 plus 2 is going to put us at +1. but the y-coordinate is the same at -8. So our starting -1 plus 1 full cycle will tell us where that cycle ends. One full cycle is from the bottom point to the bottom point. From the bottom to the top will be half, horizontally is half of a period. That says the top is going to happen at 0. And the y-coordinate of everything at the top is 2. From our bottom to the middle going up is going to be 1/4 of the period. So 1/4 of the period is, perhaps label, 1/2 the period is 1/2 of 2, or 1. 1/4 of the period is 1/4 of 2, which is 1/2. So -1 plus 1/2 is -1/2. And all the middle points are at -3. Each quarter period step is a 1/2. So from -1 to -1/2 to 0. The next one will be at +1/2. The next middle will be at +1/2 and still -3. We identified the 5 things that we want to identify, 4 number things, and our start based on the plus or minus sine or cosine. We drew out 1 cycle and labeled the 5 major points of the 1 cycle. So you have a good idea about what this graph looks like. Any questions? That's everything, okay? I gotta be more careful with the period because here I said it's 1/4 of 2, but it's like 5 after 2. So I'm like, oh, when I'm like, oh, 1/4 of 2, you're like, oh, no, 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 it's, oh, okay. Right. Like reverse time. I'm sure it feels like that sometimes in math class. I want a remote control clock where I could turn back time like halfway through the lecture. Just make sure no one has looked at the clock for a while. And then just like press a button and it rewinds it back half an hour. So students are like, oh, man, we should be close to the, what do you mean we just started? Like math distorts time, but that would be kind of cruel and unusual. But technically, I'm not punishing you, so I think I can get away with it. My favorite time trick was back in the day, I would teach back in building 3. Does everybody know which building 3 is? Building 3 is a common feature among schools. They're temporary buildings that are there just forever. So those buildings, those temporary buildings have been there since I've been here. And they were rusty when I came here. So they were been here for a while when I came here, 20 something years ago. But apparently, so 20 years ago, it was more common for phones to go off in class and for teachers to get mad at phones going off in class. Anybody have a teacher that gets mad when someone's phone goes off in class? If your phone goes off in class, just silence it. I think we should be at the point now, if your phone accidentally goes off in class, I don't think that's considered rude anymore. It's like, oh no, and then you just like silence it and then you put it back in your pocket. There's no reason to do anything more than that. I don't understand someone that gets mad about this. You know what I mean? It's like early on when cell phones were not very common. I was like, oh, this is a crazy disruption, right? It's surprising. But now it should just be commonplace. It's like a car alarm. No one cares. Your car alarm is like, help, I'm being stolen. And like no one reacts to it anymore. So it's like, oh, oops. Don't even say anything, just silence your phone. But anyway, in that classroom, they had like the worst placement of clock ever. The clock in the classroom was here, above the board. So everybody's like sitting there staring at the clock. Imagine if this class was facing that wall. And so all you would see is the clock. It didn't matter. I could set myself on fire. People were just like, oh, watching the clock. The problem was there was a professor that taught in that class. I don't know who it was, but they were really annoyed that people's phones were going off in class. But instead of putting a sign that says, please silence your phone, or please turn off your phone or whatever, they just put a sign that said phone. Now, I have a friend that does this. He'll walk into a grocery store, find someone that works there when he's looking for something. And instead of asking them like a full fucking sentence and say, excuse me, where can I find the potato chips? Like, human beings talking to each other. Just be like, oh, potato chips? I'm like, oh, that's not a question. I'm all the time like, well, that's not a question. That's a human being. Use your words. So anyway, this professor is apparently annoyed. So they just put a sign that said, phone, but they put it right under the clock. And the mistake was that in that classroom, there was actually a phone on the wall, because this is, like I said, in the day before, everybody had a phone already. So they had to put phones in classrooms in case, I don't know, some shit went down. There's like a phone in the room. And so I saw the phone and I took the phone sign and I put it above the phone, and I made another sign that said clock, and I put it over the clock. Then I thought that wasn't funny enough. So I put a sign that said board, and I stuck that next to the board, and I made a sign that said light switch, and I put that by the light switch. I don't know if they ever took my meeting, but I thought that was annoying. It'd be like, oh, phone. That's the face that they were making when they said phone, instead of just saying, please silence your phone. I mean, the theaters know how to do it. In the movie theater, they know how to do it. You know what I'm talking about? I mean, like they used to watch movies in these big rooms where everybody had to go because you couldn't just watch in your living room. And we called them theaters. I don't know if you've heard of these things. And they would show movies, and they'd have this big giant screen, like bigger even than the one that you might have at your house. I'm like, oh, please silence your phones. And you know what? Someone's going to forget. One of these days, someone's going to forget, and their phone's going to go off, and it's only going to happen right when the movie gets quiet. Like, no one will notice, like in a Fast and the Furious movie, because it's just loud all the time. But there's going to be some scene where like there's like emotional shit happening, and something there's going to be like the movie, it's like real quiet, and there's two characters just staring at each other, and that's when the phone's going to go off. And the correct answer is just like turn your phone off, like as fast as you can. Just silence it as fast as you can. If you're in the theater, the best reaction is to not say anything, because if you start making noise as well, you're literally just making the situation worse. Like if the phone goes off, that person knows that they forgot to turn off their phone, and hopefully they take action and turn off their phone. Do you know what I mean? And if they do that, nothing else needs to be done. If you say stuff, you're making it worse. And I think, and every time someone says something, someone whose phone goes off, I imagine my dog barking at something out on the street through the window. Because if I yell at my dog just thinks I am also yelling at the thing out in the street. So he's like, oh, bah, 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 bah. I'm like, oh, Colson, knock that off. He's like, well, yeah, let's get that fucker. He just thinks I'm yelling too. And then after it's all over, he's like, oh, yeah, we showed that thing. I'm like, oh, what was it? It was a leaf. I'm like, oh, you were making all that noise for a leaf? I'm like, yeah, a leaf. I'm like, oh, dude, it was just a leaf. You know what makes leaves shift? Mountain lions. Maybe it was a mountain lion sneaking through the leaves. I'm like, oh, you're right, bud. That mailman was coming in here to murder us, and you stopped it. High five, give him a clip. All right. This is going to be our new project. We just want to do these sinusoidal graphs, and we want to do them in radians. On Thursday, we are going to practice this some more. An additional announcement. I forgot to reschedule Zoom. I'm limited in the number of Zooms that I can schedule in advance. And that ran out in October. And I forgot to reschedule it. And so that's why there wasn't one scheduled. But they are back on the schedule. I'm still recording. I'm also behind in my posting of the recordings. So hopefully all those recordings will be up today and we'll be all caught up with our stuff. That's it for today. I'll see y'all on Thursday. Everybody have a good day and thanks for playing.